So hello and welcome to our today lesson. We're going to look at structure and bonding. This is a Form 2 topic that it's very simple and easy to understand, though it always confuses some students. So atoms of the same or different elements actually usually develop a force of attraction between themselves, and this force of attraction is referred to as chemical bond. So in structure and bonding, there is one key thing that you need to know. We are forming a chemical bond. So one thing you need to note is that in just a small summary is that atoms are electrically neutral due to the presence of negatively charged electrons and positively charged protons and neutrons which do not have a charge. Okay. And then number two, one thing you need to note is that noble gases are electrically stable with an electron configuration of 2, that is for helium, and then we have 2.8, that is neon, and then the last one is argon, which has 288. All right. And all other atoms, okay, hope that you can be able to follow me closely. So all other atoms can achieve the stable electron configuration by either 1, they can gain by gaining, and 2, losing or sharing of electrons. So the first kind of bond we're going to look at is ionic bond, and is also referred to as electrovalent bond, electrovalent bonding. So it involves the transfer of valence electron from one atom to another. And a good example is this. We have a reaction between sodium and chlorine to form sodium chloride. So sodium is found in group 1, chlorine is found in group 7. So when we're doing this particular structure, you realize that we are indicating that this has how many number of energy levels? 1, 2, 3. And this one has also the same number of energy level. But in the outside energy level, we have 1 electron, and this one has 7 electrons. So this is going to lose 1 electron to this, and then this one is going to gain 1 electron when we are doing that. So I want to go into deep details drawing that so that you'll be able to understand what I'm trying to put across. So I want to bring this one here so that I draw as you see. So this is sodium, and it has 1 electron on the outside, but it has 1, 2. Let me try to indicate that way. Then it has 2 here. So that means sodium has 281 electron configuration. And then we have chlorine. We are going to use dots to represent that. It has 7 in the outermost energy level, then 1 here. So when they form, we expect that this one will lose this 1 to here, and so we are going to have 1, 2. And then we're going to have a positive sign, because now we have more number of protons than electrons, because we have lost 1 electron. So we're going to have 8 for sodium ion. And then for chlorine, we're going to have more electrons. So So let me try to draw that. I'm going to have 8. But now this outermost energy level will have another electron which is from sodium, and so we are supposed to have a sign here which is a negative sign. Okay, so that's how it will look like in terms of structure. So this will be chlorine with a negative sign, and the configuration will be like that. All right, so this is a bond we call ionic bond. Ionic bond, in essence, that we are losing one electron and transferring that electron to another atom. All right, so that's a good example. You can do practice on maybe the following: potassium chloride if you get time. You can also try sodium chloride, draw that kind of structure, and also try to draw for which one is it there? Is it let me give you maybe lithium chloride. So you can try that at your own time and see if you can be able to draw a similar structure or bond of this caliber. So to explain more concerning ionic bonds, we will just try to define it in easiest terms possible. And an ionic bond is just a bond formed when there is a complete transfer of valence electron from one atom to another to form two ions having opposite charges. And mostly this occurs in metals plus nonmetals, therefore ending up forming an ionic bond. Good examples are this, and I had given you other one earlier, so you can try to write, draw a structure for these ones. Now, something more you need to know that, because our topic is about structure and bonding, therefore the ionic bond has its own structure, just like a skeleton in which it has. And that structure, we refer to it as giant ionic structure. And a good example of this case is sodium chloride. So each sodium ion is surrounded by 6 chlorides, ions that actually are equidistant from sodium and vice versa. And I'll give you an assignment. You'll get that picture very well when you look at KLB on page 66. So this pattern actually repeats itself, resulting in the formation of a giant ionic structure. Okay, so other actually compounds that have giant ionic structure include sodium potassium nitrate, we have sodium iodide, we have potassium bromide, and we also have calcium nitrate. The table below tries to show the summary of that, the physical properties of ionic compound, and these are some of them. I'll not go much into details concerning that. So you have any question concerning this, please ensure you leave them down in the description below. I'll be able to actually try to answer as much question as possible. So I want to discuss only 3 physical properties of ionic compounds, and one will be solubility. And one is that most of them are soluble in water, since water is a polar solvent. And then their melting and boiling point is that they have high, since ionic bonds are strong, hence a lot of energy is required to break this particular kind of bonds. And lastly is electrical conductivity, and ionic compounds do not conduct electricity in solid state due to the absence of mobile ion. However, in molten or aqueous state, the ions are mobile, and therefore the conductivity, they can conduct electricity. Right? So those are the three properties of ionic compound that I can address in this particular lesson. So that's all about ionic compound or ionic bond. And our second bond that we need to look at is covalent bond.